Charging and discharging capacitors. This is a very simple circuit. It's what's called an RC circuit. The resistor in it limits the flow of charge. We've got a 1.5 kilo ohm resistor there, so we can watch the charging and discharging more easily because it's going to limit the flow so that the capacitor takes longer to charge up. Any capacitor could have been used here, but what I've done is I've used a 4,700 microfarads again because that's going to give us more time due to the equation C equals Q over V. If we've got a very large capacitor, then for a fixed voltage, then obviously it's going to take longer. If you just look at that equation, it's obvious. So that gives us again plenty of time to see what happens. To watch the charging here is a voltmeter placed across the capacitor. So you can see there's a voltmeter there placed across the capacitor. And for fun, I've also got to put in an ammeter there. And anyway, so let's do it. So I'll just take that away so we can reveal. There. Right, so what we're going to do is just throw on the... I'll just show you the actual circuit there. So there's the capacitor. So that's the very large capacitor. And in there is the resistor, the 1.5 kilo ohm resistor. And here we have the measurement for the current and the measurement for the voltage. So I'm going to throw it on. All you need to do is just take a measurement every 10th of a second, yeah, because you're going to see a counter displayed, so you'll be able to do that. So I'm going to switch on now. Right, so I would start doing it now, yeah, because we've got the maximum there. So every 10th of a second, just jot down this voltage. You might have to just pause the video every now and again. So just keep going. As you can see, you probably noticed that it started off really quick, and now it's kind of slowing down to a crawl. Now, so it goes really quick and then really slow. And the voltage, we're actually running 5 volts, not 6. So once it gets to 5 volts or very close, then we'll stop. So you can see now it's crawling along here, 4.92. So when you plot this out, you'll see that there's hardly any voltage movement at all now for every 10th of a second. You know, you've got about a hundredth of a volt for every 10th of a second now. It's probably even slower than that now. So yeah, so I would say that's there. So what I'm going to do is switch off the power supply, and then you can just see how it backs off. So that takes a bit of time before that shuts down. You'll see the needle flick across the other side now. So now we're at the maximum on the other side, and now you'll see the voltage start to drop. So you can do the same thing again now. You can just take a reading every 10th of a second. Down it goes, down it goes. Started off very quickly, slowing down, slowing down. Eventually we get to 0, and once it gets to 0, that's this tutorial over. On the next tutorial, I'm going to cover the analysis of this, so you can actually see how to get the curve that you're going to plot there. You're looking at nature at work there, which is quite nice to see that. So you definitely want to plot that out, because that's you've seen what I've done. I mean, you might have done this experiment yourself. If you just plot it out, then on the next lesson we'll go through some analysis, so you can actually produce that same curve, but just purely analytically, and that's a really nice way to be able to get to the maths. You know, do this first before you get to the mathematical side. It'll just make a lot more sense. So see you on the next video.